You're listening to AI Podcast. I'm Daniel, and today we're unpacking a study from ICLR 2025 titled Agent S, an open agentic framework that uses computers like a human. With me is Maya.
Hi, Daniel. I've got my tea and I'm curious. Give me the headline first.
TLDR, Agent S is an open framework that lets an AI use a computer much like a person does, by seeing the screen, understanding the interface, and taking step-by-step actions. The recipe combines structured planning, a memory of past attempts, and a language-friendly interface to the desktop. On a tough benchmark called OS World, it lifts success by about 9 points over the baseline, roughly an 80% relative jump, and it also transfers to Windows tasks without special tuning. That's the core story.
So this isn't just a chatbot, it's a digital operator that clicks and types through real apps, right?
Exactly. Think of it as a careful, patient assistant that can open apps, follow menus, type text, and finish a multi-step job.
Who's behind it?
The work is led by Saaket Agashe with colleagues at Similar Research, and a senior author is Eric Wang. It appeared as a poster at ICLR 2025.
All right, what problem are they trying to solve?
Computer use agents face 3 persistent hurdles. First, knowledge changes constantly, so an agent needs current practical know-how. Second, many tasks require long horizon planning, not just a single click. Third, user interfaces are messy. An agent must pick the right element among many and act precisely.
Right, and earlier systems tended to stumble on those?
They did. Many relied on raw screenshots or loose coordinate clicking and struggled to stay reliable across long workflows. Some newer efforts improved grounding, especially on Windows, but overall, success still lagged far behind human performance.
So what's Agent S doing differently?
2 main ideas. First, experience-augmented hierarchical planning. The agent breaks a goal into subtasks and consults 2 kinds of experience: web knowledge for how-to guidance and its own past runs for what worked before. It also writes summaries after each task so it improves over time. Second, an agent-computer interface, or ACI. Instead of just pixels, the agent gets a screenshot plus a structured list of on-screen elements, and it's limited to a small, safe set of actions like click, type, scroll, and so on. That constraint helps the model reason clearly and reduces compounding errors.
That sounds like moving from a noisy picture to a cleaner labeled map of the screen.
That's a good way to put it.
How did they test it?
They evaluated on OS World, which has 369 desktop tasks on Ubuntu across everyday and professional activities, and on Windows Agent Arena to check transfer to Windows. For the backbone models, they used GPT-4 and Claude 3.5 Sonnet, paired with OCR to label text on the screen and a small embedding model to retrieve relevant memories and web instructions. They compared against the baselines that come with those benchmarks.
And the results?
On OS World, the overall success rate jumps by roughly 9 points over the best baseline using the same backbone, going from around 11 to just over 20%. That's notable on a benchmark where every few points are hard-won. On Windows Agent Arena, it also improves without special tuning, which suggests the approach generalizes across operating systems.
Encouraging, but what are the caveats?
A few. Their most detailed component tests were done on a stratified subset to keep compute manageable, which is reasonable but smaller than the full suite. Reproducing exact numbers can depend on proprietary backbones and live web search, which introduces variance. And comparisons across agents aren't perfectly apples to apples, because different systems expose different action spaces and perception channels.
Do they talk about the remaining failure modes?
They do. The stubborn issues are planning missteps, picking the wrong UI element in crowded screens, and mid-task recovery when things change unexpectedly. Those are classic long-horizon control problems.
If you had to explain why this method works, what's your take?
The memory piece gives the agent useful hints at 2 levels. full task summaries for planning and step-level examples for execution, web lookup supplies, current app-specific guidance, and the interface forces each step to be explicit and interpretable. Together, that turns general reasoning into steadier GUI control.
Where does this go next?
A few directions stand out. Scale and clean the memories so the agent recalls the right examples at the right time. Improve grounding by pairing the structured element list with stronger learned UI detectors. Distill the multi-module planner into a lighter policy so it runs faster. Expand evaluations, report variance across runs, and test under changing web results, and aim for parity with strong open models to make reproduction easier.
Nice. Before we wrap, give me the one-liner a listener should remember.
Agent S shows that mixing experience-aware planning with a language-centric interface can make desktop agents more reliable. It doesn't solve everything, but it clearly moves the field forward.
Clear and helpful? Thanks, Daniel. And thanks to everyone listening. This has been AI Podcast. Until next time.